Okay, well, we're going to get started today. Thanks so much for coming back to day two of our NREL CIP workshop. I'm going to kick us off just for a little refresher on some housekeeping. So first of all, it's nice to see everyone chime in the chat yesterday. So if you're a new participant, or if you want to repeat, you can put your name and pronouns, company. If you have a company website, LinkedIn, or contact information you want to share in the chat. It's always interesting to check out the land acknowledgement for where you live. NREL is on Ute, Arapaho, and Cheyenne land, people's land out in Colorado. I'm in Boone, North Carolina, remotely, and this is primarily Cherokee land here. And if you want to add a short sentence about your interest, your company, or your interest in CIP, feel free to carry on in the chat there. Um, so yesterday we went through a few important topics, mostly overview of CIP and topic areas, and then a tour of a key part of what CIP tries to fund is turbine testing and certification. Today, well, we also fund through CIP projects involving listing, which is, the certification of electrical components and turbines. And Joe Sposi from RE Innovations will take us through an overview of turbine and component and inverter listing processes. And then our Dave Snowberg from NREL will go over the design review or design evaluation that is part of several of our topic areas in CIP. And then Kendall Jackson, and she works with NREL Acquisition Services, and we'll go over some details on procurement and contracting with NREL. And then Scott Dane and I will wrap up with some additional CIP considerations involving technical assistance opportunities from DOE labs through CIP, and some other loose ends to button up. And then really excited and hope you'll stick around or come back if you have to go take a break to the final, at least half an hour CIP discussion. We're always trying to improve CIP, and we'll be looking for some feedback on some ideas to make it more effective for the industry and for you at the last bit of the session today. We'll see how it goes with a break, and but please feel free to add questions in the chat, and raise your hand if you're able. Do you have a raise hand function? Someone want to try that? I don't have it, but maybe because I'm a host. I don't have to raise my hand. But either way, we're looking for any questions you may have along the way, but especially in that last dialogue part. All right, I see some raised hands. Thank you, Heather and Robert. It works. And then as a reminder, until if and when an RFP request for proposal for CIP is released, we're free to talk about things. Once it's out, we can't. So I've blocked off tomorrow uh, from 8 a.m. to 2 p.m. Mountain Time, office hours. If you want to meet tomorrow, something while it's fresh on your mind, either about your project, any questions you may have, any further thoughts on CIP improvement, just send me an email and I'll send a Teams invite for a short meeting tomorrow. Again, just a reminder that NREL has released a notice of intent to release a RFP in early 2025 for another round of CIP. There's the link to sam.gov, but it's also on the NREL CIP website, which is easy to find. I always just Google NREL and CIP, and there it is. And a reminder that we're kind of presenting information on past CIP RFPs. There's still lots to do to build the next round, and we want to release it in the best way possible. But what we present here is based on what has happened in the past. There's no guarantees of what will happen in the future, even at this point, even though all we can say is we do intend to release an RFP. So if you want to be added to the CIP email list so you can be alerted to the release of the RFP and the next workshop and other CIP announcements, just email Kendall Jackson and she'll add you to the list. And again, there's the CIP website. You guys did a fine job. You people did a fine job of keeping yourself muted unless you needed to ask a question. You can raise your hand, put them in the chat. If you do speak a question, just briefly introduce yourself. And a reminder that thank you, Heather Rhodes, for helping distribute some links regarding our Distributed Wind Conference here in the U.S., Distributed Wind 2025, set for late February in Arlington, Virginia. You can find out about that and register at distributedwind.org. And we do have a LinkedIn group. So the idea to set that up was, and I'll put this in the chat when I'm finished, is to establish a place for teaming. Maybe you're looking for an inverter to be tested and listed, and you'll possibly can meet up with a lab that has that capability, or maybe you're looking for a consultant to help with your project or your proposal, or you just want to be stay abreast of CIP announcements and other conversations. We can keep working on this LinkedIn site, and hopefully it becomes even more invaluable. That's it for a kickoff for today. Any questions before we get started? Thank you for putting those links in the chat. We got the LinkedIn group, Marriott reservations for the conference. I can't really give a hint on when the RFP will be released. It may be a little different this year as the new administration comes in. So all we can say is we tend to release it in early 2025, but I'm not able to nail that down at this point. Got it. Okay, so our first speaker will be Joe Sposey from RE Innovations. If you're active in CIP or distributed wind standards, Joe's a busy guy, and you probably know him. A very invaluable consultant in this space, and looks like Joe is successfully sharing his screen and will take us through an overview of certification of distributed wind technology to electrical standards under CIP. So thank you very much, Joe, and thanks everyone again for coming back.
Sure. Can you hear me okay?
Yep, I hear you just fine.
Okay, all right. So
Joe, can I give out one more reminder? We're recording day 2 as well, and both day 1 and day 2 will be posted on the bottom of the CIP website shortly for asynchronous viewing later on. So thank you, Joe.
All right, thanks, Brent. And thanks, NREL and team and DOE, of course, for this workshop. Again, happy to be here, happy to participate. Thanks for the opportunity. And thanks, of course, for the program, right? CIP has been a great program, been participating in it for a long time. It's been a long time running now, 12 years or so. So happy to be here to talk to you today about certification of distributed wind turbine technology to electrical safety standards under the CIP. You heard the team yesterday talking about the different solicitation topic areas that could potentially be awarded. I'm going to focus a little bit on some of the electrical certification parts of that. I'm not going to focus so much on like the statement of work. That sort of stuff is publicly available. You can find it, the deliverables, things like that. I'm going to focus a little more on the actual certification requirements. I'm with Renewable Energy Innovations. We specialize in wind turbine design, testing, and certification. We are not a certification body, but we're a service provider that provides design and certification advisory services and type testing. But we help define the path and the plan to certification, right? You heard that said a few times yesterday. Path and plan and certification, right? Those words were used often. And we've done that in the CIP through our innovation since 2020 for 18 awarded projects now. We're participating in actively and have participated in over the last 4 rounds. And that's heavily focused really on the ACP 101 testing. That's my area of expertise and background. I help customers set up third-party wind turbine test sites where we do the ACP and IAC testing at your facility. But various things we've been and I've personally been participating in the CIP since 2013. So why am I here to talk about electrical? Well, I have a background at Intertech with electrical safety certifications and general North American third-party certification. And over the years, I've just continued my way through the electrical standards and involvement in standards development. So I'm here to talk to you and give an overview of the general certification process in North America. And then we're going to hit some details on the turbine system certifications, 61, 41, 42. We're going to talk about some common turbine components and their certifications. We're going to hit inverter listings along the way, and then circle back onto the CIP topic areas where some of this stuff could be covered. Last year, I gave this presentation at the workshop, and not a ton has changed. That information has been available and posted, and I think Brent said they were going to take it down and replace it perhaps. So this is being recorded and will replace. There's a lot of similar info with some updated information. We've added inverters, like I said, National Electric Code still there, 61, 41, 42 still there. No major changes, still the same additions. And we'll still talk about those things. The what's different perhaps is more the adoptions, where you're seeing enforcement of the different codes and standards across the country. And then, like I said, we'll talk a little bit more about inverters this time than last time. And then also since last, I have authored and published through NREL the Distributed Wind Certification Best Practices Guideline. This document is directly available on the REI website. You can also download it there directly via the link. Thanks to NREL and DOE for helping to publish this document. It's a 100-page certification guidance document that runs through North American certification requirements applicable to distributed wind turbine applications above and below 150 kilowatts. The stuff I'm going to talk about today is very much more in detail covered in the Distributed Wind Guide, certification guide. So I encourage you to download it. It's a key tool for planning and preparing for the CIP. And like I said, everything I'm going to talk about today is in more detail on the guideline. There are checklists and tables and things that'll show you what's applicable for your given component and in much more detail than what we're going to talk about here. So what drives us to comply? Why in North America? Why do we have to certify? I get asked that question all the time. It really is baseline quality, international standards for certain products, and it is really just establishing the initial baseline for a quality product, quality wind turbine, but also for mitigation of certain risks. Certainly on the electrical safety side, right? Electrical safety certification is for risk of mitigation for risks of shock and fire and hazard. So that is exactly what it's for. But also electrical certainly comes into play in permitting and zoning. Electrical permitting, you're going to see, we're going to talk about that. We're going to talk about maps and enforcement. And then same with locally with grid operators and local municipalities, that again with adoption and utility enforcement requirements. The electrical, I want to note importantly, right, the electrical standards, electrical certifications are typically not required for eligibility for the tax rebates or the incentive programs, ITC, PTC, USDA REAP. Those all refer to ACP, IEC, OEA, right? Not the electrical standards. So just want to be clear on that. But it is also important for export markets. You heard it also mentioned, IEC and other markets in Europe, the machinery directive, right? There are other markets that require certifications as well. So if you want to market the product outside the US, it's also to your advantage. And I apologize, I am going to try to fly through as much of this information as I can. The info will be publicly available for you. And I'm also available for questions afterwards. Right, so the overall system in North America is commonly referred to kind of as the three-legged stool. It has 3 layers to it, if you will, on the left-hand side being National Electric Code, which really drives the other 2 layers. National Electric Code is applicable to really any product that's connected to the electrical network, from household appliances to wind turbines, right? So there's special parts of the code and the latter sections of the code where Article 694 is for wind turbines. They'll have specific wind turbine requirements, and that's where the items in the top right come into play, where turbine systems and components shall be listed and labeled for the application, right? That's wording out of the code. And 61, 41, and 42 are directly referenced. That what that means is, the turbine, the system of the turbine has to be certified. That's done at the factory. That's evaluated by a third party before it even makes its way to the field, right? NEC, National Electric Code, is kind of just checking that everything complies. And then similarly, grid interconnection being the other layer. The inverter is certainly an element there that falls under 41 and 42, but usually is kind of a beast of its own, grid interconnection, and has varying requirements from location to location. First, let's touch on National Electric Code briefly. Again, not a lot has changed. Still Article 694. All components still shall be listed and labeled. Still references 6141 and 6140 42. Still applies to all the components, major components, surge protecting devices, wiring methods and raceways. But basically what I've done is, I encourage you to also do on your own is to check up on the maps, right? I checked this map. This is updated since previous. And the main thing I'll note related to adoption is now 37 states have now adopted 2020 NEC or newer. And this is up 6 from last time we had this conversation. And this is important to note because 2020 code is the version of Article 694 that first brought in 6141 and 6142 and listing of the electrical system. So those you see there in purple and white, right? Those are the states where you're going to start to see the latest set of requirements being implemented by local authorities. And then before I really dive into the different certifications for the components and things like that, I do like to talk a little bit about some terminology for certification, common terms. A wind turbine system is a classification listing, is what that's commonly referred to, and that's what will be applicable for any wind turbine system being certified. People always even just ask me, what is a listing, right? A listing is literally just a public listing of a certificate or certification records and documents. But that listing is usually done by a third-party accredited, nationally recognized testing laboratory, NRTL, right? In North America, that's all maintained by OSHA. They audit, they accredit, and maintain the laboratory accreditations directly with the labs. And you can find all those labs on the OSHA website and all of their scopes. Right? It's easy to find who can do what. So a classification listing is used for a grouping of components or subassemblies, right? You've got an inverter here, a generator there, a controller, right? You've got pieces and parts, and as a system, they have an applicable standard, right? 61, 41, or 42, and so that's a classification listing. Other than that, right, is at the component level, is just a listing or a recognition listing or a recognized component. Excuse me, that's at the component level, subassembly, and also subcomponents, right? A listing, right, is a full compliance with the product standard, A to Z. Good example of this is an inverter. There's no conditions of acceptability. That falls under a recognition or a recognized listing or a recognized component. That's sorry if CSA is still here, right? The UL, the UR mark, right? The R, that's a recognized component. CSA, Intertech, they all have their own certification marks and labels, and they'll have their R or something to denote a recognized component, which basically means it's incomplete on its own, needs to be used into some other assembly, and is common for things like generators and controllers where they have those conditions of acceptability, like for a generator that says shall be connected to a 1741 listed inverter, right? The generator on its own doesn't connect to the utility, the inverter does, and so that affords you some exceptions to the generator requirements. There's other evaluation types, limited evaluations or things like that for unlisted components. I don't normally suggest that, but it is what's done. If you have unlisted components, it's usually just as rigorous, sometimes more costly, and there's usually additional surveillance on the back end. Field labeling or evaluation of unapproved single turbine systems that have already been installed but aren't approved or certified is still done in the field. And that's a single applied label by the NRTL. It's usually right to National Electric Code, but other product standards are brought in, certainly 6141 and 42. Okay, 6141, 42, turbine system classification certifications. This slide is really just to show the similarities between the two. In my opinion, the two could be the same document. They don't need to exist separately, but they do. With the major difference being 6142 for small turbines is where users or service personnel cannot or are not intended to enter the turbine in any place. And 6141 being the opposite, right? Service personnel enter the turbine either in the tower base or in the cell or both to perform maintenance or service. So that's the fundamental difference between the two documents. Other than that, the requirements are pretty much the same. 6141 does have some other standard references in them. For example, switchgear and transformers in larger turbines are operated at higher voltages. So there are some other standards that are referenced for higher voltage values. But aside from that, the requirements are pretty much the same. The other big difference in 6142 is where you're going to find all the requirements for turbines that are intended to be utility connected, interconnected. That's not in 6141, mainly because that's large turbines, not one-off installations, wind farms, things like that. If you are, so to note, if you're a larger turbine that has entry, but you are being used in an application with utility grid interaction, like a distributed wind application, behind the meter application, then you have to comply with the utility grid interaction requirements of 6142, even though you're a 6141 turbine, right? So depends on the application as to what sort of grid interconnection requirements you have to comply with. And then 6141 also, of course, has service personnel requirements in it. This is just a table of some common components on the left-hand side. On the right-hand side is the reference standard that the component shall comply with, basically out of 6141 or 42. If you see 6141 or 42 mentioned, that means that the standard pretty much defines the requirement on its own. For example, rotating hub has some requirements in it and also points you to the design standards, 61400 for the actual mechanical design of the equipment. We're going to talk a little bit more about some of these things, the generators, controllers, et cetera, on the next couple slides. But I would suggest for a full list of components, go to the DW guideline, right? There's a list of reference standards, all these components, subcomponents, and things are referenced within the guideline. You can also go to the standard, Appendix A, at the back of both 6141 and 42 has a very long list of reference standards that are required for subcomponents. I'm not going to read all of this. I possibly have enough time to do so. So we'll hit a couple of the high points, but I like to flood this slide with some useful information. Again, you can refer back to this at a later date. For alternators, generators, and motors, you really just need to be prepared and know what you have before you walk into the certification process. And then it's fairly simple. Most commonly, the biggest piece of information I always give is related to the installation system. It has to be UL 1446 listed as a system of components. That means you can't grab, even if they're made by the same company, this part, this part, this part, all certified individually. If they're not certified as a group of components, as a system, then they are not UL 1446 certified. And that could be a potentially longer road for you. But the most important piece of information in the UL 1004 approval process for a generator is the temperature test. I talk about this in the guideline. There are some exceptions. Basically, if your windings never exceed 105, I have 100 here, that's a Canadian requirement, but 105 degrees C in the windings, then you are what's a Class A insulation system, the lowest level, and you afford yourself some exceptions along the way, and it makes it easier. And you don't have to worry about having a UL 1446 certified insulation system. So that's about just the planning element, knowing what you have and what you need and what your temperatures are before you coming into the certification. Control systems and equipment aren't very well covered in 6141 or 42, but there are loose references. If not covered, you go to these standards, right? It's generally going to require you to refer to the IEC 61400 design standards for control systems, fail-safe design, risk assessment, braking system design, right? That all comes out of the 61400 series. You have to demonstrate functional safety. We've done a couple of ways, in my opinion. We focus on physical testing. So there's a lot of coordinating with safety and function testing to make sure we do adequate field functional safety testing. And the components and subcomponents of the control systems and equipment have to be listed or otherwise approved, right? So evaluated by the certification body, and there's some applicable standards there, but many really do apply depending on the components. There's some pointers there on things you should always do about sourcing components, bill of materials, being prepared. Pay attention to those things. Motor drives, VFDs, not a ton of new information. All I'd really like to point out is that there are in the US, this was an international standard. UL adopted it, but took national deviations. And in doing so, they say in the very last clause that if there's power conversion in the device, that you also need to go to UL 1741 for conversion compliance. So it's an interesting topic, honestly, because the 61800 standard is also acceptable for inverter and converter constructional safety, right? Just the actual basic safety elements. So it's an interesting topic, but just a point I like to make. And then also, if the VFD has power coming from the utility directly, mains power directly, there are always going to be some additional protections there, disconnects, things like that to be considered. That's all covered in the product standards. Converters, out of the inverter standard 1741, but you don't apply supplement A, you don't apply supplement B. You go through the main part of the standard that covers power conversion elements. And then, of course, planning. Refer to the guideline. There are several parts of these that can all be coordinated together, certainly when it comes to environmental testing. On the inverter side, Brent, how are we doing for time? I've only got a few more slides. We should be okay.
Fine, Joe. You're doing fine.
Should be good.
Yeah.
Inverter listing is, generically these days, I should say latest and greatest UL 1741 SB, supplement B is what's being enforced. And I note that UL 1741 is what's generically required in both 6141 and 6142 for inverters, converters, and controllers. It's not dated, doesn't say, certain, but usually that means that you use the latest and greatest reference when applied. So an NRTL would probably agree with that statement and would just go to the latest supplement B version of the document. But that doesn't mean you're being applied supplement B automatically, right? That just means you're using the latest version of the standard. Clauses 1 through 71 can be applied to many electrical components and equipment that are general electrical safety and performance and ratings and markings requirements that are just broadly applied and don't necessarily apply only to inverters or whatever, right? That can be applied to converters, controller equipment, etc. Beyond clause 71, that's where you get application specific charge controllers, PV equipment. You get into supplement A and supplement B, right? And that's where the utility interactive devices come into play. So it comes down to the dated versions of 1741 and IEEE 1547 or supplement A, supplement B that you have that will dictate compliance in a given jurisdiction. We'll cover that in the map I believe it's on the next slide. It is important to note that there are options or different paths regarding compliance in 1741, and I believe this to be an SB specific thing. Right, there's 3 sort of options. You can still complete the certification path and be 3 different types of utility interactive device. One being just plain utility interactive, right? And these are labeled as such, utility interactive on the label. And this is just the old method, the old versions of the standard. And this would be acceptable in some of those regions where you don't see the color shading on the map, right? It's the old school anti-islanding, get out of the way. The grid cuts out, you disconnect. There's nothing to worry about, right? This is more commonly referred to as UL 1741 basic, if you will. It doesn't necessarily extend to the IEEE standards even sometimes. This is often a stepping stone towards the eventual SB. Sometimes you can achieve this along the way, satisfy some of your markets, and then keep working towards SB. Option 2 there is really what they mean when they say SB, right? Grid support utility interactive is the full breadth of the standard. Latest IEEE 1547 references or SB, you're riding through. Grid is down, we need support. There are communication requirements where the utility needs to be able to communicate with the device. This is the most strict. And unfortunately, what we're starting to see more commonly in some of the states that we're going to show on the next map. There's also special purpose utility interactive, which is defined by you or the inverter OEM or the utility. Maybe you're in a certain application that has parts of SB that are required, and you can easily do those. You can get a special purpose utility interactive designation. It's still third party NRTL label. It just says special purpose, and it clearly identifies what functions are or are not included, right? So you wouldn't be able to take it into another market and claim it to be full SB, right? It identifies what's what. And then lastly, on inverters, people do ask me all the time, are PV inverters okay? And I mean, they are, as long as they're listed and used within the ratings. SB obviously would be advisable. But usually you're now adding some other equipment, or you're doing something differently. Maybe you're tricking it, in the program to do something a little different. So those gaps are always addressed whenever you use a product kind of in a different application. But nothing wrong with the inverter. Sometimes, the old Windy Boy or whatever had that other box, the rectifier box, and that's common. There's some other box there that wasn't ever listed, right? That box now adds to the cost of the certification, adds to the complexity. But yes, the inverter is fine as long as it works for your system and is listed. This interconnection maps, I did grab an update of the one on the bottom right. The one on the top left I couldn't find. But again, I'm just clicking that link, right? And this website actually is fantastic. There's a ton of information about adoption of the IEEE 1547-2018 standard. More than I was expecting, honestly. When I first went there, there's a ton of information, that map's there. But that map on the bottom right is actually from January this year. So I would suggest coming back in a couple months. Maybe I'll do another one of these sometime down the road, and we'll update this map, because I think there's a couple of states that aren't showing the color shade there that should. But this map is showing you in those shaded states basically where you can expect to start seeing the full breadth UL 1741 SB being enforced. Okay, all that. Why CIP? We've seen the updated numbers, the awards over the years, the moving towards funding electrical, right? So let's see some of the different areas where we can cover this under the CIP. In the top right-hand corner, you've got last year's topic areas and award amounts. So some of those, don't show here, but we could look back. Prototype design development, maybe one of those solicitations, if offered, topic areas offered that could have some electrical elements. Usually this is more towards the theoretical design of the turbine. That's all on paper, right? But you're specing components, wanting to make sure that you've got the right generator and electronics and inverter, right? The building out your BOM, that all relates to electrical. The prototype manufacture and installation, not usually electrical in scope. Prototype install and testing, also not usually. That's primarily used for getting ready to do the ACP 101 or IC testing, but may have some electrical tests in there during the installation for commissioning or things like that. Component innovation, system optimization, I think, are two prime candidates always for electrical related scopes. Component innovation, right? You could be already having a listed inverter component that needs to be optimized, improved, something changed, right? That's a prime candidate for component innovation. System optimization, maybe, I think I heard Ian say, right, that would be more like you've got a system of components that needs to work its way towards the certification. So obviously you're swapping out a whole bunch of things, right? Or even maybe some of them are certified, right? But you have a system of electrical components inside the nacelle or whatever that all need to be evaluated and optimized towards a certification. That could be handled there as well. And then of course, both the small turbine certification listing, solicitation, and the type cert cover electrical elements. You see for the small turbine listing had 220, my face is in the way, I think, 220 for turbine certification and 80 for turbine electrical, right? And that turbine electrical, in my eyes, is 6141 or 42, assuming you've got some unlisted components, right? That's like the cost to get some components through the process, maybe a generator, part of the control system, and an overall 6142 or 41 certification. The inverter listing topic, of course, right? I think the higher end of that price range is more applicable to larger inverter sizes, maybe above 100 kilowatts as you increase in size. The difficulty in finding, securing, and scheduling the high power test labs for that testing increases, and the cost increases accordingly. Manufacturing process, of course, right? Again, you've got this electrical component, you want to innovate, maybe a new innovative process, or you need to change to a more scalable process. And then maybe the last, the product, one of the more recent ones, product commercialization and market development. You really not electrical in scope, but there again could be some electrical elements there, other markets, other certification requirements, production line testing, things to ensure that the product is ready for those other markets. Again, these are all just some of my ideas. Check with Brent, check with Ian, right? Here's, try to put some estimates on time and cost. First on cost on the right-hand side, and I'm running short on time. I'm almost done. The inverter number should probably really be about 50%. So sorry about that. I'm going to update that. Maybe it's about 50% of the cost. The other things are going to shrink down. Then you can go back to that table above, that 200K number for the inverter, and you can start to put some numbers here that make sense in my mind, for some cost estimates. And then on the left-hand side, the time estimate, the turbine system obviously doesn't include the inverter, but it does assume you've got to do a couple of these things along the way. And in that, you should be able to still reach about a 6-month time frame, if not sooner. If you're also making the inverter, you add that to your time frame, but usually you're getting that from someone else, procure it off the shelf, or have them go through the listing process. Right, and that was it, right? I think we went through everything. Just a couple minutes ahead here. If you guys have any questions on the certification, the topic areas, the costs, timelines, any of it, you can ask me now, reach out. Happy to partner and help in these projects as well. And thanks for the time, guys.
Yeah, Joe, thank you for your time. We had one question in the chat from Josh Grollo. Do wind turbines need to be listed to UL 61, 41, 42 prior to interconnection to the grid? Who enforces this? The utility? And Chris Connor weighs in that not usually required for interconnection, but may be required by the authority having jurisdiction of safety approval.
Yeah, on the permitting side, 61, 41, and 42, like I said, it would be required by 2020 code or later. So that's now 37 states. So in theory, yeah, and right, that's a big color code. That's at the state level. That does not mean those maps are at the state level. That does not mean at the local municipality level they've caught up. They may have their own set of requirements, right? But 6141 is, I would say, far less enforced, for example, than 1741 in the grid interconnection side. But yes, you will see it more and more as later editions of the code are being adopted around the country, right? That's just because you're able to work in older editions of the code, and some parts of the country just haven't caught up yet, or made revisions to their grid where they want interoperability and things like that.
Right, and just point out that I sit on the NEC code making panel 4, and so does Robert Wills. We both pay attention to the wind section, Article 694, as well as others, to make sure nothing bad happens in those meetings. And the National Electrical Code, Article 694, doesn't say much. It says equipment, wind electric systems shall comply with one of the following: be listed or be evaluated for the application and have a field label applied. And it has an informational note about UL 61, 41, and 42. And then finally it says wind electric systems undergoing evaluation for type certification and listing shall be permitted to be operated in a controlled location with access to limited qualified personnel. So it does give a little exception for those undergoing testing in the field.
Sure, even temporary. Those are possibly temporary installations even sometimes. And yeah, temporary installations do not always have to fall fully under the code. But yeah, reference to 61, 41, 42. And that's right. So that's what the inspector is going to look for.
So it doesn't say much, but the underlying details is kind of a sea of standards and, a relationship with a NREL and a test laboratory to ensure that all the little bits and the full system is listed. So, there's a lot to cover, but thanks for covering as an overview. Yeah. Any more questions for Joe while we have his time, a couple more minutes of his time here?
Yeah, definitely a difficult topic to cover in a short period. That's why I say go to the guideline, right? There's a ton of information there.
And I did I did put the link to the guideline in the chat for folks.
Perfect. Thank you.
Thank you.
All right, guys. If anything, let me know. I'll be here.
Excellent. Thank you very much, Joe.
Thank
And
you.
thanks everyone. If you have any questions on that, let us know on CIP side and let Joe know on the Joe side. And I don't see any more in the chat, so I think we're covered for now. Thank you very much. So I see David Snowberg here. David's has been with NREL for a while. We're happy to have him on the CIP staff as a technical monitor and proposal reviewer, as expert in manufacturing and wind turbines and other things. And um, Dave's agreed to go through an element that has been a part of many of the CIP topic areas for many years, which is a design review with you, the awardee, and lab-based experts, mostly from NREL and sometimes from other labs. So thank you, Dave. The screen looks great.
Okay, thanks, Brent. Does my audio sound okay?
Yes.
All right, screen share is working. It's a good start to a presentation. Yeah, thanks, Brent. So happy to provide this overview of the design review evaluation process for CIP subcontractors. Let's see if my screen will advance. There we go. So these are all the different topic areas that have required design evaluation or design review go no-go decisions in the past. And just to back up a little bit, the reason that we do these types of design reviews and go no-goes is to early on in the subcontract, we just want to make sure that the plan is in place and the pieces are coming together for success. So we want to make sure if there's any issues that we can help to identify them and provide some recommendations to mitigate those early on. Because in the end, we all want our CIP subcontractors to have success in their subcontracts to deliver what they've proposed, and we're here to help with that. So while these are go no-go decisions, we primarily are using them to help provide feedback early on and provide recommendations to be successful. So prototype design development, prototype manufacture and installation, prototype testing, small turbine certification and listing, type certification and inverter listing. All these are the different CIPs that have these design reviews. So a big part of all design reviews for any of those topic areas starts with loads. So having a good understanding of what your loads are is very important first step to really understand what your system is, how it's behaving, and through the modeling of that, and then being able to take those loads and doing analysis and developing the designs around them. So, and of course, depending on whether it's a prototype or type certification, the load development would be at a different level of maturity. So that's certainly understood. Safety factors are going to be applied to loads. Those are going to come from the standards, whether that be the ACP 101, the IEC standards, or others. Certainly refer to the relevant standard to come up with both your load cases as well as your safety factors, as well as the blade test requirements. So that is an important part of the certification process of distributed wind. Depending on the size, it will be required, and depending on where you're at in your development, you may just be making plans for it, or you may already have it completed. So now I'm going to go into each one of those topic areas, a slide in each one of them. And I should say, for anyone listening, if you are awarded a subcontract through CIP in the future, we being NREL would provide you with guidance and templates and such for what the expectations are for a design review. So you don't need to be frantically jotting down notes in all these slides, but just wanted to provide an overview to help understand what the expectations are. So for prototype design development, this is the earliest stage of a product development under CIP. So it's with the design review here, it's primarily going to be NREL subject matter experts, potentially other DOE national labs may be involved, potentially DOE would participate as well. And at the concept design evaluation at the prototype level, we'd be looking for load estimations through the technical concepts that are being developed through this CIP, performance estimations, cost, and then responding to the opinions of the design reviewers. So the intent of this evaluation at this step is to ensure that you're ready to progress to producing a prototype that's potentially technically and commercially viable. That's certainly the goal for any development here. And it's anticipated that there's going to be challenges. There may be some gaps in what's presented and what's needs to be done at that step. So we would provide that feedback, and then with addressing of those gaps going forward, things would progress through the subcontract. The next topic area is the prototype manufacture and installation. This would also have a design review, similar group of people involved in participating in that review. And this would provide, be a detailed technical review of the concepts again, with the loads. Loads is going to be a part of every topic area here, probably, except maybe inverter listing. Performance estimation again, cost. So similar to the prototype design development topic area. And this is ensuring that pieces are ready and that the plan is in place that makes sense to the reviewers, that you're ready for prototype construction. So that would be the go, no-go decision there. And ensuring that this is, on a path towards certification. That's a key part of all CIP, is that developments are aligned with certification, heading towards certification, and that is a part of the plan. And ultimately, cost of energy is king, and that's going to be always important to make sure that products are competitive in the marketplace that are being developed. So prototype testing is another topic area. So this one, a similar group of people involved and similar review of the aspects of this design review of technical concepts, including loads, performance, but also the testing effort. So this is where the test plan would be put together and reviewed, and just making sure that the testing efforts that are being planned make sense. Again, heading towards certification, even though we're at the prototype testing stage here. Always want to be keeping an eye towards that goal. And here again, there'll be go, no-go decision, and intent to ensure that turbine will benefit from prototype testing in its current configuration. Certainly want to make sure money is spent wisely and that the test doesn't, make sense, that it's the right test to do at that stage. So important to make any changes before starting on the testing program, because tests are expensive. Small turbine certification and or listing, another topic area with the design review. And the intent of this review is ensure that the turbine to be tested is likely to pass the structural design review through the certification body. So this is be done with a similar group here at NREL and other DOE labs and DOE. And intent here is to review and make sure that the project, the turbine development, is ready for certification testing. So this is essentially a preliminary version of the limit state analysis. Refer to the IEC 61400-2 for details on what that means. And this is happening before the certifying body is involved, typically, or in parallel. But this type of review would help to align efforts and make sure that you're on a path to success for that review by the certifying body. And certainly loads is a key part of this, aeroelastic modeling, the work you're doing to validate your model, all of that would fit into the topic area here and what would be fit into a design review. And for listing, the design evaluation would consist of the review of the equipment being listed and the documentation that's being required by the nationally recognized testing laboratory, NREL, as we call them, for that listing project. All right, type certification under -1. This also has a design basis evaluation. So in this case, there's 2 go, no-go determinations, and this is based on the work that you're doing with your certifying body. In this case, the process would happen by evaluating what the certifying body has determined. So the design basis evaluation is one step, as well as the design evaluation. All of this referenced from ICRE, OD 501. With that reference there provides the steps to go through for this process. And in this case, the copy of the conformity statements for both the design basis evaluation and design evaluation would be provided to NREL for this review. So this would be reviewing the outputs from the certifying body for this case. Inverter listing, this one is, I think, the last one for the different topic areas that currently have in the past required design reviews or design evaluations. And in this case, we're reviewing the details of the equipment that's being listed for this inverter, as well as reviewing the initial NREL quote for the listing, just checking that things are, the scope makes sense, that it aligns with what the expectations are for this effort. And then things look good, that there'll be a go, no-go decision there as well. So what to include for a design review? Certainly start with your standards. So IEC standards, the ACP standard, UL, whatever it might be that you're certifying to, that's the first and probably most important place to start for what the requirements should be that you're working towards. But with any wind turbine system, there's some key things that are always going to be there. Loads, for example, and control systems. Wind turbines need to have robust control systems to survive what we put them through in their environment. So description of the control system, having an eye towards fail-safe redundancies within the control system is important. There may be some condition monitoring depending on the type of turbine that you're developing, and certainly have a test plan for safety and function tests for your turbine. So that's one aspect that should be included in a design review. Also considering the design load cases. So within the IEC-2, there's 3 different ways loads can be determined. Simplified load method, which is only recommended for on the smaller side of turbines that fit under this scope. Aeroelastic simulations, that's probably the most common way of coming up with your loads, whether that be open fast, bladed, or other aeroelastic modeling tools can help you develop those models and loads. Or full-scale load measurements, that's another way under the IEC. That's not always included under other standards, but that's one way you can come up with your loads. And many with different loads to consider. Again, refer to the standards, but aerodynamic loads, inertial, vibration, seismic, gravitational, operational loads. Transportation can be an important load as well, depending on how machines and equipment is transported. Also consider loads of installing your turbine for tilt-up towers. So make sure that those loads are sufficiently modeled and acceptable. So important to do all this, and this is part of what we would look for in a design review of is your approach to coming up with your loads and then what you do with them. So minimum set of design load cases here, shown from this table from -2. This is, -1 has a similar table for load cases for larger turbines. But it's important to comprehensively look at your loads from your modeling effort or other ways of coming up with loads, and then present them in a clear and organized way. So when you're looking at design load cases and analysis, it's important to look at all the relevant components of interest, certainly tower, blades, your shafts, and other components will be key parts to be analyzing, coming up with your loads and analyzing them. It's important to look at all the different load cases, because sometimes you might be surprised at a certain load case comes up with a higher load than you were expecting for that component. So it's good to be comprehensive in your approach here. And then here's an example of showing different load cases for the blade root moment. An interesting thing shown here, design load case 2.1 here for the blade was quite a bit different on the one blade versus the other two, and that might be understood to why that's happening, but maybe that flags something to look into a little deeper and why you have one blade being so much different than the others. And whether that's real or not, that's always a challenge, but it's important to look at all your load cases and then apply the safety factors per the standard. And you want to be looking at your ultimate limit states, your fatigue limit states, and other limit states that may be called out in the standard. All right, and then when it comes to limit states, it shall be verified the limit states are not exceeded. It must be coming from one of our standards, which is what the analysis step should be doing, where you're taking your loads, you're doing your analysis, you're looking at applying the proper factors on your loads, the proper factors on your materials, and ensuring that you have adequate margins between the two. So within that, also want to be looking at a modal assessment, ensuring you don't have any resonance that could cause you challenges. Good to mitigate those early, not discover that you have a resonant problem after you've already committed to tooling and production and such. So Campbell diagrams can help with that process to help identify some of those vibrations and frequencies to avoid, and include all the components of relevance. So within ACP 101, that calls out the blade root to hub connection, hub, main shaft bearings, yaw shaft, and IEC calls out all components. And then, again, ultimate fatigue and service limit states are the limit states to be looking at for all these different components. So pretty comprehensive, but it's important and valuable to do that early on in your development. So for all components of relevance, these are some of the items to include: eigenanalysis, finite element analysis, explanation of your boundary conditions, your loads, your material properties, safety factors, your manufacturing process, quality assurance, quality control protocols, and then of course all your standards that you're working towards. And again, calling out the static load test that's required for the blade, the rotor blade, which is only for larger than 1 kilowatt turbines from ACP 101. And it's understood that if you're developing a prototype, potentially you just have plans for that blade test at this design review step when you're still developing your prototype. but it should be something you're thinking about. And for these design reviews, we ask you to summarize in a PowerPoint presentation so that folks like shown here can be in a room and either whether it be virtual or in person, work through the design review and be able to provide feedback and have a productive discussion. So some of the key takeaways here. This presentation is not meant to be exhaustive on everything required, but it does provide quite a few details on what expectations would be for a design review. But first step here, again, read and understand the standards or hire somebody who does understand those, because that's going to be a key part of your success through CIP is to understand the standards and be working towards them. Certainly we want you to be scientifically rigorous, show that the decisions you made were based on data, based on good reasons. Pay attention to documentation format, version control, figure numbering. Keep it clean, keep it easy to understand and reference, and not be a mess to read. It's not going to help reviewers in their understanding of what you're doing. Use best engineering judgment and be prepared for feedback. I mean, we may ask for some clarification on items, ask for more information. There may be some new actions that come out of that, but this is a requirement for NREL to provide a go no go on these CIP subcontracts. So this is an example of a template for a design analysis report. So as well as the presentation, there is a deliverable, a document to put together that summarizes the design that's being reviewed. So this template would be provided to you if you have one of these subcontracts to help you structure your information in a way that we can read it and understand it. So won't read all this, but get an idea of some of the information here, describing the system, the control and protection system, what's your approach to modeling, some of the analysis results from the modal Campbell diagram, all your design load cases, your FEA or other analysis methods, what those results are for all these key components, your operating and maintenance provisions, transportation, installation, manufacturing, safety, function, conclusions. So, and then appendices here being installation instructions, other potential operating maintenance instructions, cable connections, tower options. So that is the template, or one of the templates for a design review. And with that is the end of this overview. And I'd be happy to answer any questions, as well as Brent would be happy as well, I'm sure.
Well, excellent, Dave. Thank you so much. That was a good overview of that. Like Dave said, it's actually a great opportunity for you to get your design file together, because I know you're headed toward certification and you can't start thinking about these things too early. And also you get some face time with experts at the lab, and some candid feedback and questions, which will help you uncover some opportunities to look further into your design, improve your design, and improve your documentation. So any questions for Dave on design reviews or design evaluations? Noted in the chat these days, even though that was a cool picture of everyone crowded in a room doing a design review these days, it's been virtual meetings such as this, which is why it's very handy to convert your report into a slideshow to step through these items in a virtual meeting. Okay, well, thank you, Dave. Really
Yeah, thank
appreciate
you.
that. Thank everyone for your attention. If you have any further questions, you can put them in the chat or send us an email. Okay, I'm gonna look at my agenda and I got too many things open. Not sharing my screen today. So next we'll hear from Kendall Jackson on procurement and contracting details. So Kendall, were you going to share your screen or would you like me to do that?
Either way, I have the slides pulled up if you'd prefer.
Yeah, go
me
for
to
it.
do
It seems
that.
to be working
Okay.
fine. So let's let you run your show there. Thanks again, Dave. See you.
Yeah, thank you. If you can take the screen, I'm having a hard time unsharing, so
Yeah, I think she can steal it.
that'd be great.
Request remote control. Okay.
Share. You see the share button there
Um,
on the bottom?
no, but let's see. It just changed.
Mine's a little green up arrow in the bottom of my toolbar there. If you have that. If not, I'll pull yours up.
It may also be located in the more icon if your toolbar is
Mm,
condensed.
could be hiding under the more icon.
Okay. Is this on the
Zoom toolbar.
Zoom or
Mhm. Yeah.
okay. I don't see it. I see
Yeah, no.
captions, breakout room. Oh, here we go. I see the share now. Okay.
All right, cool, great.
Okay. See if we can figure this out. Okay. Let me just get in present. Okay, does that look good?
Yes, thank you, Kendall.
Okay, perfect. So like Brent said, my name is Kendall Jackson. I'm a subcontract administrator for the acquisition services group here at NREL. I've been working with the CIP program for a few rounds now, so pretty familiar with this program, but I'm just going to go through a few details regarding the request for proposal. So if and when that is posted, it'll go up on sam.gov. That's the system for award management.gov. The instructions for how to submit a proposal will all be identified in there as far as the subcontract information type, the requirements, the due date, that'll all be identified there. The timeline, just based on past rounds that we typically have seen, the RFP has been posted in late July with submission date around late March. We try to have awardees selected in the summer with the goal to complete negotiations by the fall. There will be an opportunity for you to ask questions. So once those are submitted, and there will be a date identified in the RFP as to when those are due. And then once those are submitted, we will post an amendment again to that sam.gov website. And basically all of the questions that were received will be identified in there as well as NREL's response so that everyone that's interested in the solicitation is seeing the same information. And there could be subsequent amendments as well. We've done multiple in the past. It just kind of depends on the kind of traffic that we receive on questions. Once we get the proposals in, we start the review process. So these are based on best value selection, meaning that we look both at qualitative merit and price. Those qualitative merit criteria will be identified again in the RFP. You'll have information about the different areas and even sub-criteria. And within that, it'll also identify the different weights that all of the merit criteria is weighted against. So you'll know what has the most value. We then go through the evaluation process. Initially, we just kind of go through the proposal to make sure that everything that is required has been received. And then at that point, we may reach out for clarification. Then the proposals that all meet that first step go through the evaluation process against both the statement of work and that merit criteria I mentioned before. And at this point, we may reach out to vendors or offers for discussion on anything within the proposal. And then once all the proposals have been scored, successful and unsuccessful offers are then notified. And then we enter into negotiations with those successful offers with the goal of making an award. So these do require price participation. Again, this amount will be identified in the RFP. An example from previous rounds, most often these are required to have a 20% price participation, and this is just based on the type of work that's being requested. The price participation will be built into a payment schedule, which I'll go into more detail on in the next slide. But these are firm fixed price agreements. So subcontractors will be paid based on completed deliverables, and a part of that that you'll demonstrate in your proposal is how that price participation factors into those deliverables and that payment schedule. So common types of price participation include labor, equipment, supplies, and as far as what is considered allowable, I've provided the federal acquisition regulation part, which is 31.201-2, and that can give you some more information on what is considered reasonable and allocable under the FAR and DOE regulations. There will be an opportunity for offers to identify proprietary and restricted data in their proposal. We'll give you a disclosure statement that you can put on the proposal, basically identifying anything that you believe to be proprietary or restricted. We just like to point out that this does go through a legal review. So sometimes we've had offers state that, you know, the entire proposal is proprietary. And while we understand that this is confidential to your organization, and we won't be sharing, you know, any of this information with anyone that's not privy to it, being myself or the evaluators. We just have to make sure that that information that's being identified is in fact proprietary or restricted. It can't be anything that's widely known or something that's on your website. So we just ask you to be selective in what you put in that disclosure statement. Part of the proposal will also be to provide your acceptance of statement of work, terms and conditions, both general and intellectual property, or to request exceptions to those. And then the forms that are required are a price cost proposal, an organizational conflict of interest. There's two different forms, either a representation, basically stating that there is no conflict, or a disclosure where you disclose what the conflict may be. So you only need to fill out one of those two forms. And then anyone that hasn't done business with NREL in the past, we require that you submit a W-9 as well as the banking information. And then the last one here I have is the representations and certifications. That's a form that you'll fill out, and a part of that is to identify your SAM registration. I like to point this out now because it can take time. I know some people, it takes a couple weeks or even months to get through that process. So we just like to give you a lot of heads up about getting that completed beforehand. This is that payment schedule that I was talking about before. So within the proposal, you'll identify what all of the deliverables are in the statement of work, and then you will assign a value commensurate with the amount of work required for each of those deliverables to assign to each of these deliverables. And within that, you'll identify both an NREL portion and a subcontractor portion. And that kind of lays out how you are meeting that 20% minimum was the example used on the previous slide. So that's just where you will show us how that is being met. Property and equipment is defined as anything that has a useful life or value after the completion of the effort. So I just like to point out that anything that NREL pays for legally, we are entitled to that equipment/property at the end of the subcontract's period of performance. That is often not our intent or desired outcome that we retain ownership of it, but just legally we are entitled to it if we pay for it. So we just like to point out that if you are going to have property or equipment on your proposal, we encourage offers to identify that as your price participation, because if you are paying for it, then that's just much cleaner, and it's the question of ownership just doesn't become potentially an issue. And then lastly, just wanted to point out for invoicing, again, successful offers will be paid based off of these pre-negotiated values in the payment schedule. Invoices are paid upon submission of approved deliverables, and instructions for how to submit invoices will be identified in the subcontract award. So that is all I had. Here's my email. If you're not already on the list of interested vendors to receive the proposal or the RFP notification, please feel free to email me and I can add you to the list. But were there any questions?
Heather had a question in the chat, and hope she says, "Are applicants able to claim the updated 15% de minimis rate?" And she provided an energy.gov link. I don't know what that means.
I have not heard of this.
For indirect cost. It used to be 10%, and as of October 1st, my understanding is any federal solicitations that have come out after that date, this new rate kicks in, and it also has increased for lower tier subs. You used to only be able to take on the first 25,000 of each contract, and that has been raised to $50,000. So I just was wondering if that had flowed through to the NREL system yet.
If I can look into that, because I am not
Great.
really familiar with that. So I'll look into the 15% minimus. And then what was the lower tier?
It was 25,000
Okay.
per
Mhm.
lower tier sub, and now it's $50,000. That's if you're doing like modified total direct costs,
Okay.
which usually goes along with the IDC rate.
Mm-hmm.
Yeah.
Okay. Let me look into that and I can let Brent, Ian know, or I can also email you directly. And if we need to make that a part of the amendment questions, I'm happy to do that too.
Or just, yeah, in the RFP.
Sure.
I've noticed a lot of the solicitations going out are mentioning this 2 CFR Part 200.
Okay. Well, thank you for bringing that up. I will look into it.
Sure. And then Brent, I emailed you, or in the chat, another question.
Uh-huh.
Did you see that?
About the concept papers?
Yes. Yeah.
Yeah, so we're going to discuss that in the last round today, trying to get some feedback on the value of the concept paper round we
Great.
tried last round, and some ideas on maybe ways to do it slightly differently this round. And so we'll maybe hold off on that until the discussion part, if that's okay.
Perfect.
Great. Any more questions for Kendall on the contracting side of things? Okay, great. Well, thank you very much, Kendall. Thanks a
Thank
lot for
you.
that. Yeah,
Of
very
course.
helpful.
I'll just
People
quickly
ask,
make a point, but if a solicitation comes out in late February and it's due in late March, it's not much time, right? So
yeah.
especially spring, spring break, a lot of people have stuff going on. So
Yeah.
encouraging the applicants to get started sooner than later. Yeah.
Mhm. Good feedback. Thank you, Heather. Okay, thank you, Kendall. Then we're gonna segue into presentation from Scott Dana and I, both from NREL, on some additional CIP considerations. After this, we'll get into a discussion part where we can we encourage you to give us your thoughts. But at this point, we're going to start with technical opportunities for technical assistance. And there's Scott Dana now. Good to see you, Scott. Thank you for running this part of the show. I'll just run the slides and let you speak to them if that's okay with you.
Yeah, that sounds great.
All right. Well, thank you, Scott. Scott, how long have you been at NREL and what do you do here?
Yeah, I've been with NREL for 12 years. I'm a researcher in pretty much in field testing and validation. Yes, a lot of standards, interpretation as it goes into testing and analysis. Yeah, do a lot of work in wind and across renewable technologies at NREL, and I've been with CIP for I think about 6 years now. I've had the definite pleasure of working with some of the longstanding participants and seeing the proof in the pudding here as we've gone from concept to prototypes and going into certification testing. So it's been pretty great.
Great. Thank you, Scott. All right, off you go.
Yeah. So one facet of CIP that we've included for a number of rounds, maybe all of them, as certainly as things have matured a little more, is some technical assistance capability from NREL and slightly beyond NREL. We do have some other DOE laboratories that we can engage with, like PNNL, INL, and Sandia, which you may have all heard of before. But the assistance options are pretty broad. So just about anything maybe you're struggling with, we could provide some kind of help in one way or another. But we certainly are very familiar and seasoned in modeling and the standards side of things. We have people here that are working on those committees to develop standards. So we know they can often maybe not read the same to everybody. So we can help with some interpretation there. We have, world-class team at NREL on the controls side of things, and electronic side of things, inverters, all of that nature. Test site requirements. We have very capable personnel when it comes to structural testing. So things like your blades or your towers for static pulls, or even if fatigue is required. We also have a number of dynamometer facilities. Most of them are probably a little bit larger than what would be needed for this space of wind power. But we also have a smaller 5 kilowatt or 225 kilowatt, skid mounted facility. And we are very capable in, the design of an experiment. And if we need to modify something and adapt it to your system, that's certainly within our wheelhouse. And we also have, grid testing capabilities, inverter testing capabilities in our Golden campus, and we're adding more of that at the Flatirons campus, which is kind of the larger complex, open area complex of NREL, where we have a lot of at scale field experiments. And then moving along, modeling and just decision support. So we also kind of on the softer side of things with performance assessment and market penetration. There's some tools there, and we have experts behind those that can help you. And then with hybrid optimization and performance as well. So that's kind of a pretty broad brush overview. I wouldn't say it's totally inclusive, but keep it in mind that we can answer probably a lot of questions you might have. That said, we really do very much encourage you to reach out to industry for these kinds of supports. We can still find ways to help you under CIP to cover those costs, but we don't, as a federal entity, we don't want to compete with industry. So we'd really prefer that you look to the private sector first when you're trying to find support. But don't hesitate, because we can help maybe guide you in that right direction as well. Another really important aspect of the technical assistance is if you expect you need technical assistance in some way, please try to capture that in your proposal. It's very helpful for us to understand, kind of your line of thinking and your path to certification, and if that includes needing some outside technical support, whether it's through NREL or the private sector, we would like to know that up front when we evaluate the proposals, and if possible, getting dollar amounts around that is very helpful. We understand, the timescales can be lengthy. You might not know exactly what you need, but if you can engage with somebody that can provide, with some kind of third-party support, and they can give you some kind of estimate around what that support is going to cost, that's also very helpful for our evaluation and budgeting when we go back to DOE on these things. So please keep that in mind. Yeah, and a proposal can be pursued if the request was not included. So don't if you didn't have it in there originally, that's okay. We prefer it was captured, but if you didn't have it, we can still add that on during the award. That we've done that a number of times. We understand it's very dynamic going through this process, depending what stage you're at, and through the development process, you might say, oh wow, we suddenly need this kind of extra support that we don't have the capability of in-house. So we can help support that. I think that's about it there. Yeah. So yeah, I think we'll go through a quick kind of rundown of some of what NREL is able to provide some of our facilities. So I mentioned structural testing. You'll see in the pictures there, we've got a small tower on a test stand. We're doing some static and fatigue loads testing. There's a blade on a wiffle tree there where we're doing, again, some loads testing. So we're, we've done this for a living for a very long time. So we have a lot of capability, a lot of equipment, sensors, load frames, test stands, cranes, all of those kinds of things where we can measure loads and forces and strains. We do have some specialized test equipment that maybe is not quite as accessible, like in the non-destructive realm, for example, with acoustic emission and thermography. And we do have a digital image correlation system as well. All right. Yeah, as I mentioned, the 225 kilowatt facility, you see it there mounted in one of the high bays, but it has been transitioned to a kind of a mobile platform. So it does give us a little more flexibility to put this in one of our high bay facilities. We have a few of them on the site, and we can kind of reconfigure for testing your generator, maybe generator coupled with power electronics, an inverter, or just a gearbox, or we can, vet the full kind of drivetrain. So, kind of from rotor through the drivetrain to power electronics, all of that is capable here. Yeah, so microgrid testing, that's becoming a more hot topic. We see this quite a bit more, wanting to understand your turbine and your technology as it interfaces with the grid. So we currently have a controllable grid interface with a second one coming online, hopefully soon. It's been in the making for a little while, and that the latter specifically is more geared towards the small wind testing and kind of compliance. So we can literally recreate almost any kind of grid event possible and understand, quantify how your system and components kind of handle or ride through that. So a little more advanced, but you know, there could be a lot of learning done there, and really as you know, standards and compliance is changing all the time with interconnections, this could be a pretty valuable technical assistance opportunity. And then we do have quite a bit of solar PV, fixed tilt and tracking systems at Flatirons, at the main campus in Golden, that we could do some hybrid style testing as well. Yeah, here's a little bit of an overview splash of some of the things we've done in the past. So we've done some blade testing. We've supported some FOT testing, air elastic support, even really high fidelity component level on magnetic modeling. There's an example of some strain gauge work that NREL has supported. So that's another thing to keep in mind. We have in the past been able to come to your turbine, your site, and help with instrumentation efforts and calibration efforts, leading into maybe like a prototype testing or certification style testing, where, you know, some of those things are not so trivial, and there's not a lot of available public domain knowledge. So we've been able to support some of that. So keep it in mind. Again, if we know it's coming, that's better, but that's not necessarily, doesn't necessarily need to be the case. But we certainly have a lot of expertise in that space. So that, I guess that's about it.
Thank you, Scott. Any questions for Scott on technical assistance? I didn't check the chat. Let me look. Let's see. So Tim Olson says, could you describe those 3 business tools more, or show examples, provide links, tap, degen, hop? Sure. Let's see. I'll give it a shot on tools assessing performance. Yeah, that's a project that's been going for a while. It's evolved into a tool called Wind Watts, which you can search for. I'll try to put a link into it after this. You can check out, but it's a project where we've offered some technical support on wind resource assessment, essentially, and performance prediction tools. And degen there's a part of degen called dwind, where it's a analysis group project that has using GIS graphical information systems tools to overlay lots of layers of information from wind resource to county data, and provide some analysis of state, county, local level market potential. So that relates to that NREL future study. The distributed wind future study is sort of a culmination of a large study using that model, that diffusion model. And then we do have quite a few folks working on hybrid system optimization, HOP and DHOP, and some other tools not listed here that you may be interested in. I think most of them will be listed on the NREL distributed wind research page, which I'll drop in there, and there'll be links to TAP and some of these other programs on that NREL distributed wind website. And so Ian dropped in a WinWatts beta version link to from that evolved from the TAP project. And another question, so hopefully that helps Tim. And Heather says, any more details on company-specific technical assistance available on commercialization and market assessment? Yeah, that commercialization topic area is new, is still fairly new to CIP and a bit of a departure from our technical topic areas and our technical-based technical assistance. So these tools down here, we're trying to speak to a little bit about that. I think we're open to providing technical assistance on the commercialization side, but some of these modeling tools could be helpful there. Otherwise, we could reach into some of the corners of NREL that we're less familiar with if you have some specific commercialization needs around this area. Anyone else have any input on technical assistance for commercialization? Chime in, or are there any more questions? Do you still have on-site natural frequency testing capability? Scott, do you want to speak to that? Any modal testing capabilities?
Yeah, sure. Yeah, we definitely do.
Yeah, we have that capability.
Generally speaking, yeah. It depends on the details, but yeah, that's certainly something we do routinely.
On-site meaning at NREL, or you mean a portable?
We have portable systems, yeah.
Got it. Sounds like we still have that, Tim. Okay, anything else? Great. Well, thanks for those questions. GIS layers of 3 phase lines and grid hosting capability for most states. So the mapping technical assistance, we are currently offering that for a recipient of a commercialization award, and that map-based GIS-based assistance is being offered through PNNL, Pacific Northwest National Lab. So again, that goes back to this is lab-based support, and currently that mapping GIS work is being done at PNNL, and so we would coordinate technical assistance such as that using CIP funding, but performed at PNNL for the CIP subcontractor. Okay, great. Thumbs up on that. So I'm going to take the rest of this through. First, a quick overview of some deliverables and outreach materials that are outcomes. And thank you very much, Scott, for covering that. That was great. Thank you, Scott. Kendall showed, these subcontracts are deliverable based. We negotiate a deliverable payment schedule and pre-negotiated values for these deliverables. So you submit them, they're reviewed and approved. You submit an invoice and you're paid for the deliverables for these projects throughout the period of performance. All of these projects have had a common first deliverable, which is a summary of work effort describing the project. It's the first thing to work on. And then all projects have quarterly reports that come in quarterly to keep the technical monitor abreast of project progress. And then there are deliverables specific to the topic area. So when the RFP is released, there is a accompanying statement of work which describes in detail the tasks for each topic area and the associated deliverables for each of the topic areas. I will state that there are some There is some flexibility in the deliverable schedule. So for instance, a big complex deliverable can be broken up into multiple parts, providing opportunities for payments to come in more than one chunk and to spread the work over a longer period of time. And so that's part of the subcontract negotiation phase is producing a custom deliverable schedule that follows the statement of work from the RFP, but it also allows you to negotiate some slight changes and modifications to these topic area specific deliverables. On outreach materials, I mean, DOE and NREL communications, we get the word out on CIP through a variety of ways. Press releases, primarily with projects. We produce fact sheets that we talked about yesterday and post them to the CIP website. News articles of success stories. There's a end of year accomplishment report on wind energy that goes out, and we often highlight some CIP successes there, and DOE also puts out some progress alerts. So just know the materials that are not for public dissemination in the reports are marked as such. But if I go to the next slide, we're pretty clear that your first deliverable summary of work effort is the place where you can put information regarding the project all together in one report, and this information is used to generate these public-facing project fact sheets, which help describe the variety of projects CIP funds across the topic areas offered. The subcontractor will have the opportunity to review and edit these before they go out, but primarily this is the one and only deliverable that is clearly made public and therefore does not contain business sensitive or proprietary information. And we'll go, so also part of the RFP is a levelized cost of energy tool. So there's a spreadsheet and accompanying instruction page that is useful in the proposal stage, and you'll pick it up again at the end of the project. So LCOE has been a very popular metric for determining the competitiveness for the product in the effort for the intended market. Of course, you're probably familiar with levelized cost of energy, but it's all the dollars divided by all the kilowatt hours. So on the top, there's the capital installed cost of the turbine to the customer. The tool has a fixed charge rate provided. And then there's also on top of the equation, the annual operating expenses, including O&M costs and any planned component replacement costs throughout the duration of the life of the turbine. And on the bottom is the annual energy production. And so the result is dollars per kilowatt hour estimate. And the calculator has 3 columns. And so not all topic areas are LCOE focused, but some are, and therefore we want to track your baseline cost of energy, the proposed goal of a new updated cost of energy following the completion of the effort in the project, and then we reserve that third column, end of project, to complete the tool and estimate the actual cost of energy that was achieved at the end of the project. So baseline is current cost now, proposed is what you expect at the end of the effort, and then end of project is not filled out until the end of the project. So you may have 25 cents per kilowatt hour now. You propose doing an effort to take it down to 15 cents per kilowatt hour. And at the end of the project, due to all the factors involved, you achieved a 16 cents per kilowatt hour. So that's sort of that's the intention of the spreadsheet here. In the proposal stage, we're looking at what your current cost of energy is and what your projected cost of energy is following the effort to help assess the competitiveness of the endeavor and of the product. And of course, it's difficult working in someone else's spreadsheet, but we use the common tactic. If it's green, fill it in, and otherwise leave it to calculate. On the initial capital cost balance of system, you basically include everything expected in a normal installation building as described in the tool, showing your current baseline costs and then expected improvements in the proposal column. In the proposal, you justify the improvements to be made there. Even if your cost of some components increase, perhaps the effect of the project is to increase performance. Therefore, you can still have a lower LCOE because of the increased kilowatt hours in that equation. And be realistic in the installed cost as much as possible, because it's compared to realistic installed cost that's available to the labs and can be reviewed in things like the distributed wind market report. There's a tool for calculating estimated annual production. You provide your turbine power curve at a given hub height. And like most tools like this, it does some wind shearing if needed between wind speed and hub height. And you can include some losses and availability, soiling controls, grid, and other losses, just as you see in any other power estimation calculator. And again, don't fill out the end of project. That's for the end of the project. And please, please do not exceed the BETS limit. That's a red flag on calculations that seem to defy the laws of physics, which is a red flag. Yeah. So O&M costs are in there. You try to be realistic on operations and maintenance costs. If the manual costs for annual maintenance, then include that cost in there. Don't estimate it to be zero, because surely there'll be some issues that will be a non-zero operations and maintenance cost. And there is a place for replacement costs. So if a replacement for a component is expected in X amount of years, that expense will go in the replacement cost part of the tool. And anything that is expected to be replaced periodically throughout the turbine design life, such as brake pads and oil, are levelized by the tool across the span of the project. And you just enter the cost in the meantime for replacement in the spreadsheet. Okay, so that's it for the LCOE calculator. People seem to use it okay, and it's a good way to have a common tool for everyone to be using the same spreadsheet and tools for estimating this key LCOE metric. Okay, I'll just remind you that we have a LinkedIn group. It was new last year, so we've got it all over the place in the presentation, but we're hoping to really populate that. I think we have about 45 members there, and we look forward to seeing some conversations and some teaming there, including technical support for projects and proposal development. All right, any questions on those remaining items before we segue into a discussion part of the workshop? Let me check the chat. Let's see. So what about site and installation costs? Yep, that's the calculator is looking for the complete installed costs of the turbine to the consumer. So there are fields for all the categories that go into the installation of the turbine. So you estimate it best you can, but it is the installed cost of the the turbine. So you have the turbine, tower, and component costs, but you also have the balance of station and installation cost. And then Robert Preuss on the LCOE calculator clarifies that if you have the measured power curve, there's no control loss added into your losses because those control losses are already baked into that measured power curve from your power performance test. So you don't want to double count the control losses in that manner. Thank you, Robert. Any other questions? And it looks like Ian responded to a bit more clarity on GIS tools. So we do have NREL has some GIS layers as part of the DGen and DWEN project, and we do collaborate with PNNL on some of the distributed wind explorer tool work. So yeah, GIS is at both NREL and other labs, depending on the needs there. It looks like Heather's looking for grid overlay. Yep, I remember buying that. I had to buy that from Platts back when I worked, did GIS work for Appalachian State. So I don't know if the lab has it, but if you have a specific need associated with a project regarding GIS layers, reach out and we'll see if we have that. But sometimes that stuff has to be purchased. Okay, anything else? Any other questions? Great. Then I think in this format of the virtual workshop, I think everyone's been able to take a break as you needed. So we're going to jump right into the important discussion part and end the day on a lively note because we really want your feedback on some important items here. Ian Baringgold is going to join me in this discussion. I think Brett had a conflict and won't be able to join us. And if someone could reshare the LinkedIn group, that would be great. And sorry, a guidance on how to handle recent inflation in the LCOE. That's part of the evolution of the calculation from baseline to proposal to end of project. You estimate, I guess, I don't know if the tool really handles inflation, I'm not sure, but you estimate that as best you can. But when you get to the end of project, things have changed, and that's why we like to look at that end of project LCOE because several factors like supply chain and inflation affect that.
And it's going to be something that we're going to have to think a little bit about.
Yeah.
The idea was to try and kind of, you have your current one, you demonstrate what your proposal thinks it can do.
Right.
And we use that as part of the grading criteria because some of the metrics are around performance increases and LOC lifecycle cost reductions. And then the end is kind of a check-in on what that is, but the check-in is usually a couple of years later, and inflation has risen costs. We don't use it as a grading criteria, just to be clear. So we use the first part, so kind of this is what the technology is now, and this is what, based on the work that I'm proposing to do in the proposal, this is what I think the cost reductions or the performance improvements or what have you can do. And so we use that, but the end, we don't grade at the end or anything of that nature. So if your costs have gone up for other reasons, then in the report that you write, the LCOE report at the end, that's where you kind of capture this other stuff. But it's not a grading metric or anything of that nature. So you're not penalized for inflation or anything of that nature.
That's right. It's just something that goes into the final report because we like to see the the outcome of all the effort.
Yeah. So I hope that helped answer the question, Heather.
Isn't it used in comparing proposals? In the scoring part, we look at the LCOE baseline and projection. to see where the LCOE is and then the planned improvement and the justification behind the plan's improvement to LCOE, but not that third column of end of project. So yeah, the LCOE that's in the proposal is part of the evaluation process and helps the team determine competitiveness for the intended market and assess the goals of LCOE reduction if that's the thrust of the project. Does that help, Heather? Okay.
Well, sort of. I was just thinking that there's going to be a lot of different approaches to that for the applications this time around. But
Due to the volatile nature of inflation and the cost of everything. Yeah, I mean,
exactly,
that's
supply chain.
it,
Yeah. Mhm.
it was pretty wild back in yeah, COVID times too.
True,
You know,
true,
all
true.
over the place. So I guess, you know, you're right. But we provide a common tool to try to baseline the tool, but the assumptions within, you know, are up to the proposer for sure.
And so
Yeah,
Heather,
I got it.
the for this initial input, I mean, again, assuming there is a call for proposals and assuming that LCOE is still a criteria and assuming et cetera, et cetera. I mean, the idea is that you as a proposer, as a turbine manufacturer, say, at this point in time, when I write the proposal in January 2025, these are the costs that I am seeing for these, for my system, my component, my whatever it is. And based on what I'm proposing at this point in time, this is what I think my costs would be if I complete this work.
Right.
Obviously, that's a projection. Obviously, that's kind of your estimate on what you think the improvements that you are proposing will do. You justify those, and we'll look at your justification. But it's based at a single point in time. So I think that regardless of inflation and things of that nature, I think that is still a solid review criteria. And then at the end is just going back and checking to make sure. And I agree with you that we should probably provide some guidance around, are we at the end, are we really looking for this is what the cost of the system is at the end of your project, which means it could be a whole lot higher, or is it this is what you were able to save or something of that nature based on the project itself, and that I agree is not clear. Robert, you have your hand up, and given that you created the spreadsheet,
yeah, I would just add to that comment, because I can talk about way long ago. We had proposals that came in that were $1.50 a kilowatt hour or $1.25 a kilowatt hour at the end of their deal, and those are not viable projects. If you can't get your costs down dramatically lower than that, there's no market in which you're viable, and that's the first layer of cutoff in that. It's like, you know, I mean, even in California, you don't pay $1 a kilowatt hour. It's less than that. And that's the highest price market, I think, in the country. You might pay 45 cents, 50 cents a kilowatt hour on some times of day or various things. But so it's got to be reasonable. You got to be marketable. And that's where the LCOE comes in. Ultimately, if you can't get your cost of energy down to something that's competitive, you don't have a product.
Right. Thank you, Robert. Okay, well, thank you for those questions. And we'll have a fresh look at that and see if it needs any updating, but yeah, so thanks for the feedback. Okay, let's get into this discussion part for our last half an hour. Yeah, and thank you for that, Robert. So first, now I'm reminded of a conversation I had about crayons. There used to be, what, 8 colors? Now there's, I don't know, 128 colors. Things in the human world tend to evolve into the more complex. So over the years since 2012, CIP has evolved to have 10 discrete topic areas shown here. So the question here is, are the current topic areas or topic areas offered in the past adequately addressing the needs of the industry today? And we've got some follow-on slides on some ideas on possible modifications to CIP involving topic areas. But first question is, are these the right topic areas? Do we have it covered? Are there too many? Could they, are there too few? Any feedback on that for now?
And again, we've really tried to, I mean, as Brent introduced in the beginning, we started off with 2, and now we're at 10. And so the goal was to cover the breadth of the competitiveness improvement field for turbines. And so the key is this still valid, or are there things that we're missing? Go ahead, Robert.
Yeah, the one place that has always felt like it overlapped a whole lot is the component innovation and system optimization.
Yeah.
And it's sometimes very difficult to decide which is the best fit.
Yep.
And I think that's one that possibly could be merged and in a way that would just give people clearer choice and able to do it under one.
Good
Okay.
one.
Yep.
Yeah, that's a good one, Robert.
Are there any here that given today's market aren't needed? You no longer need?
Fred says need to expand to include international remote wind designs for third world markets.
Fred, talk a little bit about that. I mean, how would that necessarily be different in essence than one that we're developing for the US market? I mean, the costs will be a little bit different. Okay, that makes sense. I don't think we would want to skimp on standards. So, and even the standards are pretty lax for the really small turbines to get this idea not of a disposable turbine, but if it's a 300-watt turbine, it's not going to have a 20-year life, and we realize that, and the standards are kind of built around it. But talk a little bit about how you think this would be different. There is this question of DOE, this is taxpayer dollars, so we're not building turbines that will never be used in the US, but we could make an argument around the manufacturing of these turbines are going to be here. It's US technology, it's an export market, therefore we need something intrinsically different for third world countries that we wouldn't have in the US. I could make that argument. So talk a little bit about what you're thinking.
Yes, so in installation in a very remote area, a lot of the transport and erection costs and difficulties that we just don't have in the US come into play. And when I think of locally sourced materials, all of a sudden a lot of design ideas open up. And when I say locally sourced materials, the major mass items like tower and foundation, locally sourced. So a design that had a modular head and a control system that had a little bit more functionality to adapt to their own weather. There's some unique installation when you go super remote and very off grid. So thinking about installation, transportation, and I'm not throwing away the idea of US content. I love US content, but the tailoring of the product to remote, third world installations might be a national and international benefit, because that's where a lot of the they don't have a power grid, so you can now prevent them from burning and instead of burning, you can have them churn wind.
I think I don't think that's precluded in the current in past CIP rounds. For example, last round we funded a certification award to Uprise Energy that has a deployable microgrid towable tilt up wind system, and so the intended market is, I think, is quite flexible in the topic areas. We really focus on trying to help you get through the technology evolution to get a product that's ready to go out there.
Yeah, no, that now that I read the CMD line down low here, that probably covers it.
Yeah,
So, yeah, thank
so
you, guys.
yeah, and we have done stuff, Fred, like, so think about, one way to phrase this is think about markets in the US that are equivalent. So tribal entities, remote homes, remote cabins, rural Alaska. I mean, a lot of these, the kind of issues around how do we deploy them? What can we source locally? I think a lot of that could be addressed in your proposal around remote domestic markets. And then you add on that in addition to this, it supports international marketplaces as an export market potential. And you could, even in a proposal, you could talk about the economic benefits that export would provide for a turbine of this nature, in addition to being able to provide remote homes on tribal lands or something of that nature, fire protection. I mean, there are pretty remote places. So I think a lot of the stuff that you talk about is actually quite applicable in the US context, but it has the additional benefit of being applicable in the international space as well. And that would sit under component innovation, system optimization as well. If you wanted to, you have a turbine and you want to come up with a completely new way of deploying it. So you optimize around remote isolated installation and local sources or something of that nature. And so you're looking at modular towers and modular foundations or poured kind of shipped in concrete ballast systems, or I think a bunch of that kind of stuff you could investigate under a systems optimization.
Yeah, I see it. Thank you.
Yeah, thank you for the question. And before we get to you, Dean, I see Tim Olson in the chat is talking about budget limits and another potential merging of two prototype topic areas. So we have slides on those topics, and we'll get to those
Hold on
next.
to that thought, Tim. Yeah.
Yeah. But before we do, Dean Davis had your hand up.
Yeah. Can you hear me?
Yeah.
And I've brought this up before, and I know it's outside of really the focus of the CIP, but I still think the industry could benefit from testing around, for loads and model validation. I mean, I could definitely see a gap there in the vertical axis world. And right now there's just no mechanism. I've got a test facility. I may even have turbines that would be of interest to the industry, but I don't have any funding. It's like there's no opportunity to get this research dollars to, hey, we're really going to validate these models, or we're going to find out what drives some of the fatigue loads in different designs and that kind of stuff. It feels like there could be a category that would kind of be designed of okay, this isn't specific to a wind turbine taking it to market, but it's to further our better understanding on why do we have turbines that over here in this wind site, they've been running fine for 10 years. And over on this site, you can't get it to run a year without breaking blades and throwing blades and stuff like that. And like I said, I feel like, and I've gone, I've done my own work on where are these loads coming from? And it's like normal operation. It's just, and then all of a sudden there's a data set where it's like, whoa, these loads are twice the normal loads. And what is it? Is it a vertical wind? Is it a vertical shear? Is it a horizontal shear or whatever, right? And it's like, just kind of focusing on what makes it so hard. And we live in such a turbulent world, these turbines, that in some ways I feel like, and again, I mean, I know NREL works on this kind of stuff, but there's just no avenue for getting any dollars around kind of research.
Yeah, no, So good comment, Dean. And I know we've gotten a bunch of feedback from the airborne wind industry as well, that here in the United States, that they don't feel they're at the prototype design development stage. They're kind of one step before this. And it's that kind of research that you're talking about here, where it's you don't really, there's some really tricky questions that are out there for the industry that's keeping them from developing prototypes because they don't exactly know the kind of design envelope to develop those prototypes around. And something like this could help.
Yeah, I mean, you guys probably remember, but a long time ago, we had that field verification program, right?
Exactly. Yeah.
And it was, I think it was interesting for the industry to say, oh, this is actually what these turbines do. And, you know, I had data that showed, yeah, this turbine normally operates at 1200 RPM, but here's a wind event where it actually went to 2400 RPM and stuff like that, right? So.
Yeah.
Okay, thank you, Dean. That's good input. Even if it falls outside of CIP, it's a need and a good idea.
Thanks.
Paul Rowan, yes, I'm pretty confident that we changed the manufacturing process innovation language in the last round to be clear that it can be a component, such as the Berge Award last round is focused on just the blade. You know, it doesn't have to be your turbine manufacturing process. It can be a distributed wind energy technology component. So I'll have to double check, and it'll be in the language of the RFP, but I'm pretty sure manufacturing process innovation applies to components, including converters, inverters.
So to reduce like for a company like mine, or our manufacturing operations, we would need to partner with a turbine company then too?
No, I think.
No, I
in
mean,
your
you're
case,
selling, right? Yeah. Go ahead.
Okay.
You would just need to identify market players that would agree in principle to purchase your product. And so, yeah.
We do try to avoid funding anything to do with a standalone component that doesn't look like it has any conversations with the industry. It's just going to be a product. You know, we want to know, is someone going to use this product? And you can make that clear in the proposal.
And this comes from, there was a proposal a while ago that we did fund, which was blades for a generic 100 kilowatt turbine that might have been the Northwind 100, but not really. And so we funded that. Beautiful blade, no one's ever touched it. And so we want to make sure that whatever we do really has a path to the marketplace. So I think your inverter, Paul, would fit well into this. And the distinction between the market process innovation is that's really trying to focus on, you have a product and you want to improve the manufacturing of that product. And that's why the cost share is so much higher, because you're buying molds, you're buying a lot of this equipment to be able to make this product better. As compared to component innovation, which would be, I have this inverter and I need to value engineer it, and it will come out the other end with something better, but it's a lot more R&D work. It's not building molds and things of that nature. So if you're innovating the product, then it's a component improvement. If you've got a product and you're just looking for, how do I make this cheaper, more cheaply? I can't speak English. I want to make this more cheaply, but that's going to cost me a lot of money to do that. Then that's a manufacturing.
And it cost reduce it while maintaining the certification that you have.
Exactly.
It's also another dimension of complexity there.
Oh no, certainly, and that would be included in the cost. So obviously, with any manufacturing improvement, you're going to have to go back to the certification body and say, how do I do this so I don't have to recertify? Yeah.
Okay, we had a few comments on. Thank you, Paul, on bundling topic areas. So we're looking for ideas there. It's so we brainstormed just earlier on this concept of bundling or combining topic areas. And so we heard from Robert that, it would be great to just combine component and component innovation, system optimization into one topic area, and propose the effort, because sometimes it's hard to figure out which one you fit in. And then we heard from Tim that perhaps, if the overlap of prototype manufacturing and installation and prototype installation and testing could be combined as well. So we're looking for some input on which topic areas could be bundled to make make the process smoother. So any other thoughts on that?
Yeah, and as people think, I mean, the concern, what people have told us, I mean, all of this is in response to feedback from industry, is that even though we've made 10 different project areas, because we only do this every year and it's kind of delayed, that people are getting stuck in something, or they do prototype testing and they want to go to certification, but because they have to wait a whole nother year to be able to put in a certification proposal, there's a gap there. So are there ways that we could put projects together so you can get be pre-approved or something of that nature? You can say, what I want to do is prototype and certify. That's what I want to do. And I don't have to wait for a year in between these things and compete again and all of this kind of stuff. So we've heard that from you. So we're trying to think creatively about ways to do that so it supports the industry. Robert, I think you came up first.
Yeah, actually, I think you pretty much covered what I was pointing at, and it's especially the fact that you put in a proposal and it's probably 6 or 8 months later that you find out if you got approved, and then 4 months after that, there's another round, and you've just started on the project, and so it doesn't really flow very well. And that really is an idea I hadn't thought of that you just came up with, that you actually get be able to put in a solicitation for, okay, I want to do this, 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 and this in a series. And obviously there would still be always the no-go design reviews on each stage. But essentially you could know that you could move from one stage to the next when you're ready, which you might think is a year, but could be a year and a half or 2 years, and et cetera. That would make the program a much better fit for developing a new product and get to market commercialization.
Right. Well, let me go back to that slide then. Because that's another idea. We've got all these topic areas, and even though we just told you not to do this yesterday, what if we allowed multi-topic area proposals? So for instance, you want to build a prototype, install it, and go right into testing. Or you want to go from prototype testing right into certification, or you want to go do a system optimization and then maybe recertify if necessary, things like this. So these are the two, bundling and sort of multi-topic area proposals with multiple phases are the things we're trying to consider here. And
I realize that probably may run into contracting and solicitation issues with Department of Energy that you guys can't mess with. But it's certainly worth looking at, and obviously would be healthier for the industry, but there's always got to be channels for new people to come in rather than having 6 people doing the whole deal for the next 4 years.
Yeah, that was pretty locked up, right?
So, and at this point, we're just listen. I mean, again, CIP has been great because it's been responsive to the industry. So we're trying to get a sense from all of you what would be helpful, and then Brent and my job is to see how we figure out how to do it.
That's right.
John, you've got your hand up.
Yeah, thank you. Well, so one of the challenges that we've had, and I've talked about it before, and it's no mystery, is that sometimes folks get tempted to try to combine their prototype testing and their certification testing. And one of the advantages I see to this bundling approach is you actually create a stage gate, a process by which you can, at least at a minimum, discourage that practice, if not outright prohibit it. It almost never works out that somebody can do prototype testing and certification testing.
Oh, because there's things that happen in between, like back to
Things
the drawing
always happen,
board,
or the design changes, right? So
yeah,
you can go through it and maybe you'll pass, but there's almost zero chance that you won't look at something and go, geez, I wish I had done something differently in this one part or whatever. So the thing I like about connecting them in this way is it puts some enforceability on it, because we as a certifier can't prohibit that. It's
Yeah.
not something we can do. And so that might bring a little more discipline to this and prevent waste where people get tempted to, what do I say, try to fast track things, and then it's not in the best interest of the program in the long run.
Yeah. Thank you, Sean. And so what would we, yeah, we would figure out what to do in between these two phases, but you're right. There's a go, no go stage. Like, okay, how'd that go? Now what's the new revised plan of certification? And so we kind of pause here between the phases. You're saying that's a plus?
Yeah, absolutely. It's a huge plus, especially if you just build in that as a process and a discipline and an expectation process, because it's not something we can do. So we're not involved in the prototype testing. So we can't either force you to do a prototype test, or number two, tell you when you're ready, or give you guidance on that. We can only say, you know, we have to offer the service to anybody who is in scope and willing to pursue it. That's kind of
You faded out there audio wise, but I think I got it. So there's some support here on chaining them together, and sounds like you suggested some bundling even before we got to this slide. I don't know if I bundled them right here, but just as an example, we could go from 10 to 4 topic areas, but maybe not that drastic, but some of this might make sense as far as combining topic areas into one more broad topic area. So I know this is fast, but we're going to go to this one. What about award amounts? Are they adequate for the efforts? Are these calculations based on turbine size a little overthought? Should we just simplify the award amounts to a maximum and then put it on the offerer to propose what they need to be done and really justify the cost of the effort, given that some of the efforts do scale significantly with turbine size, such as manufacturing a prototype? You know, a 10 kilowatt costs a lot less to build than a 1 megawatt. So we want to increase them. I'm seeing the idea of increasing is good. Which ones need to be higher? I think
yes to everything you said, Brent. Yes to everything you said.
Yeah, looking back, I think prototype manufacturing and installation is probably too low. And then as we're getting into it, inverter listing might be a little too low. But some of the others maybe aren't off so far. Any thoughts?
Inverter listing is definitely way too low.
Yeah.
SP testing has just turned out to be an enormous barrier.
Yeah.
So just to be clear, I mean, the reason that we did this kind of formulaic one above, and again, we can talk about the numbers there, is because under the current CIP, we do not grade for cost. So we have this limit, 200,000, whatever the number is, and you propose what you think it's going to cost, and we don't have you justify the cost. We ask you to tell us what the costs are, but that's not a grading criteria. Now, if we bumped up this prototype manufacturing to $1 million, so that we could cover a 200 kilowatt turbine, that might cost $1 million to do that. But it certainly doesn't cost $1 million to manufacture and install a 3 kilowatt turbine. And so if we did that, we would force the manufacturers to justify the cost, and that would be a scoring criteria. So you came in at $1 million to do your 3 kilowatt turbine, you would have to tell us why you think it's $1 million, and you have to detail that out. And we'd go through it and we'd measure it, and then we would give you a score on whether we thought that was a sufficient cost. So does that make sense, or is something more formulaic better?
I like that idea, and I want to work on that project with the 3 kilowatt for $1 million.
I can almost guarantee you won't be funded. So
but
go ahead, apply for it. But I don't have high
just
hopes.
saying, maybe use your idea, not mine. Yeah, like the idea. I think prototype testing cost needs to go up. That I think could cover some of the stuff Dean's even talking about. You know, could still be covered into a prototype. I think prototype's always been one that's pretty wide open. It's prototype testing. That's been pretty wide open for you guys and flexible. So I think that's increase the budget that gives some opportunity to work on things like model validation for a couple turbine types or one specifically or something like that.
Yep.
I like the idea
Yes.
of all of them so far.
Is it really not like if I put a proposal in which had a maximum of, let's say, a prototype for 300, and I came in at like, you know, it was a small turbine, it was a relatively simple test, and I came in at 100K. There's no benefit to that. Is that what you're saying?
Oh no, I mean there's definitely benefit to that. I mean, well, there's benefit to that, but under the current system, cost is not a scoring criteria. So we say, tell us what it's going to cost to do the work, and they're really, so from a scoring criteria, if you write a proposal for lower than the maximum amount, you don't necessarily get benefit for writing a proposal lower than the amount. We're trusting you that you're giving us the budget you need to do it, and we do get a lot of proposals that are below the maximum amount based on need. Is that your question, Dean?
Yeah, it is.
I did want to put to make a note here. Joe, your point is really useful for the prototype testing, and this goes back to your comment, Dean. Right now, under prototype testing, there is nothing that keeps Dean from doing a prototype test on a turbine and diving into this question of why are loads so funky under this case. And you could develop the model development, exercising the model, collecting data from your turbine, running the turbine with the model. All of that stuff fits under prototype testing. The key is you need to be doing it on a turbine that you want to improve and put into certification. So it is a little different than this research idea that I think you were going for, Dean, which was, I just want to figure this out to improve the model, not because I want to improve the turbine X. I want to do it for the whole industry. So it doesn't cover exactly what I think you were trying to do, Dean, but it does cover some of it. And just want to make clear that developing an aeroelastic model for your turbine could definitely fit under a number of these topic areas, and prototype testing would certainly be one of them, including the validation of the models that you have developed with test data. That I would say that's perfectly fine under a prototype testing.
Okay. Yeah.
Well, we're out of time, so just one last thing. We were looking for any feedback on this DEIA assessment as part of the merit criteria and concept papers. Were they helpful? And we may do it a different way this year. Any final thoughts on those?
Concept papers. I mean,
were they helpful? A lot
yeah,
of people
yeah, they were. I think
feedback.
right. I think they were, but it's probably more work for you guys. I mean, I like the idea of the concept papers, honestly. But if you're not going to do it, I would say give us more time during the solicitation, because we're going to have more proposals that we're working on, more people. You're going to have more proposals to review, you know. So
right.
I would say give us longer than 30 days, please, and thank you, if you're not going to run concept papers. And if you but I mean, I like the idea. And would you say you only had 20? I mean, only 20 something this last round, but right, they were all competitive, right? So I mean, I thought it worked well. It did what you wanted it to. I liked it.
The more traditional way,
more time.
Yeah, the more traditional way would be to put out the RFP, and then you know the topic areas and the bundling and all that. and then we request short concept papers, provide feedback, and then you submit proposals. So we would give more time to do all that. But the way we did it last time, we
Sure.
got a lot of concept papers, and then we were like, we're not running that topic area.
Right.
So
Right.
Ouch.
So we
Yeah,
might-
Ian just pointed that out too. Yeah, in the chat. Yeah, absolutely.
right.
Thank
Yeah,
you.
got it. Okay, cool. All right. Any feedback on the DEIA assessment for those who did that? This is how it landed last time. Just looking for any feedback that you had. I
It
see
was the
you had
first time
there.
we did it. So
Yeah, it's the first time we did it. Yeah.
I think it's really difficult for small companies.
I disagree.
Well, if you've
but
got
go,
three
go ahead.
people,
Go ahead, Robert.
if you've got 3 people,
Uh-huh.
It doesn't have to be about those people. It's about the company's philosophy and how they are looking at their business model moving forward to be inclusive and to reflect local priorities and community needs. So anyhow, yeah, I don't think it has to be difficult. Okay. I think that's a perception, but you can approach it from a business model perspective.
It's possibly easier for a smaller company.
Mm-hmm.
I guess we'd have
There you
to
go.
see feedback of how it was actually, the grading was actually implemented. To know how well that worked. I mean, I worked on a proposal with folks and they were a foreign company with obviously set up a US subsidiary, but it was difficult for them to figure out how to work with it. Female participation in business was pretty normal there. So that was not so much an issue, but beyond that, it was pretty hard for them to figure out how to plug into it. And they wrote stuff up, I don't understand how much value was put on established principles as opposed to results so far.
Well, it was pretty easy to tell which companies were committed to understanding it, versus kind of just didn't take the time to look into it, I would say, just from my perspective. Go ahead, Ian.
Yeah, I was going to say, so it sounds like a little bit more kind of information on this would be useful.
Yes.
I'll say right here, Robert, that it was more around the company's principles around this idea. So if it's a 3-person company and it's not diverse, but you have a diversity mission statement, you're employee centric, you were thinking about how your turbine is applicable in wide market spaces, that's what you got scored high on. It wasn't how many people are in your company and is it diverse, but what your corporate philosophy was around
Your mission
and
statement.
thinking
Yeah.
about diversity and inclusivity
Exactly.
as part of your corporate ethos. That's what you were great on, but understand completely that that's not necessarily clear in the scoring criteria how we're gonna look at that. So that's a really good feedback point.
Yeah,
both of you. Yeah, thank you.
Okay,
Heather.
well, I know that was quick, but we ran out of time, but we got some good feedback in a short amount of time there, and now we've got to go chew on that. Any final thoughts?
Well,
I
your
did-
last bullet there about doing the concept papers after the RFP, would that
Yeah.
just delay everything?
Well,
Part of the concern? Yeah.
I mean,
we
it
have
might
to have time for that. Yeah.
Yeah. And so, I mean, it might not delay things. It might
Right.
give more, well, so yes, it might delay things in the sense that instead of a 4-week proposal period, it might be a 6-week or an 8-week or something
Yeah,
like
you probably
that,
have a
which
month.
means-
Yeah, an extra month in there, maybe for maybe 2 months after the RFP before the proposals are due or something like that, because we've got to bake in a concept paper stage.
So it would delay the release of the dates, the kind of the commitments, may delay the contracting. that kind of stuff.
Yeah, and in that stage, a concept paper would be required, whereas previously it wasn't required.
Well, no, so under NREL contracting, we cannot in the DOE context, you can require a concept paper and then you can tell people they cannot apply. So in the FOA world, you can have concept papers and there is a discourage, which means you cannot apply you can't put in a real proposal. NREL does not do that. So we could do a concept paper and we could encourage you not to put in a proposal. You can still put in a proposal and we will still have to grade it. But again, if we told you didn't have an idea and you still put in a proposal, then you probably still don't have an idea, even though you spend more time on the proposal. But we can't keep people from doing it. It's more providing guidance back under the NREL contracting rules. Yeah, I can. Yeah, Brent, if you need to run, because I know you're on Eastern Coast and it's late there, I can hang out for a little bit if that is helpful.
Okay, yeah, I mean, yeah, just conscious that we're out of time and I'll have to take my daughter to ukulele in a minute now.
Yeah.
So, but you can keep it rolling. I'm good for a few more minutes.
Okay.
I had one comment about back when we were talking about the variable rate depending on size and that sort of thing.
Yeah.
The other thing is that NREL does have the authority and capability to negotiate prices on these contracts. You don't probably want to, because that can get into not friendly art discussions, but that is another way to approach that. And I do think that for small turbines, a lot of times this dollars per watt makes the funding not really look very good. It might need to be tweaked a little bit in some way.
Right.
Maybe a little more on the so much plus dollars per watt, or not quite linear or something. I don't know, but it just seems like it for 10 kilowatts and less, for instance, it may tend to be not enough. So that was all on that, but great job on the workshop, guys. I appreciate it.
Thank you, Robert.
Thank you. Paul?
Thank you. I just had I threw something in the chat when you were, and since you put this slide back up, I thought I'd mention about the inverter listing category. It was mentioned kind of frequently that the number was too low, and I just tried to make a distinction between the inverter listing activity versus the development of an inverter, or maybe a redesign of an inverter. So there is a distinction, and I think if all you're doing is listing a design which is compliant, I think so it depends on how you're going to define inverter listing.
Yeah.
If it's a compliant design and you are having a NREL listed, that number is probably okay.
Right. It could be, it could be that you do a component innovation and then go into inverter listing, chain those together. It would make more sense. Right.
Maybe.
If there's significant improvements to the inverter required to get it to the level of SB, that could be significant, and then the SB listing is just the listing process, right?
Yeah, the certification process itself at the lab, not the NREL.
Right. Yeah, that's a good point, Paul.
I think you need to distinguish those two, because the numbers, I think that inverter listing number is fully adequate.
Yeah, for just the listing process mostly. Right. Yeah, gotcha.
But the development of an inverter is way more than that.
Yeah, exactly.
Yeah.
And even taking an SA inverter and improving it to SB and then listening. Yeah.
Right.
Okay, well, I'm gonna have to split, everybody. So thanks for the feedback. If you have any more, give us an email.
Yep, always welcome the feedback, or say you want to hop on a call with Brent or myself, and we're always here. So
Thanks.
Thanks,
Thank you.
guys.
great. Thanks,
Thank you.
everybody. Take care.
Yeah, thanks a lot.
Bye.
Bye-bye.